One, two, three, start. Welcome to Java 1. Welcome to Java 1. I'm here at the Night Hacking booth at the Java Hub at the Java 1 2016 in San Francisco. And my name is Victor Gamov. I work with Hazelcast, and with me today, Greg Luck. He's co-leader of JCache standard and the creator of JCache. Maybe you heard about this libraries and using stuff. And today we're going to talk about the future of JCache. So JCache was released in 2013, right?
Right.
The
yeah.
first version, finally, and right now we have a huge adoption of JCache. Like, how many implementation of JCache we have today?
There's now 10 implementations of JCache.
All right, so we have a 10 implementation JCache, and today we're going to talk about the future. So what we're going to expect from the JCache 1.1 or probably 2.0.
Okay.
So can you talk about how you become the JCache co-lead and how it started for you, like a JCache? So before we're talking about future, we're going to talk about fast a little bit.
Okay. So years ago, I used to work at ThoughtWorks, and we got sent out for 6-week short gig at whatif.com, and they had a very successful business model, but the website was down about 2 or 3 hours a day. So they'd get 10 or 15,000 concurrent users would come in, and then they would search for inventory. And the what if model, which is still unique, no one has actually done this throughout all of travel, is have a single web page result that comes back. So you search for Sydney, you get 300 hotels come back with all the inventory, all the information on one page. It's about 3 megabytes of data. Imagine that, and Sydney was the most requested page, for example. You get 5,000 of those per second. So they had it connected to SQL Server Enterprise in a traditional model with stored procedures and so on. And it didn't work, didn't scale. And this was, early on when that standard enterprise architectures that they didn't scale was actually not well understood by anybody. So we went in thinking, oh yeah, well, no problem. Smart guys, we'll figure something out. And we then realized, wow, this is actually a serious problem. So our starting point was to try and simplify our use of the database, and we went with Hibernate. And Hibernate really is about speed of development, not necessarily speed of execution.
But it was also asking for troubles.
It was
right?
also very, very early days in ORM.
Yeah.
In fact, we started with an internal ThoughtWorks library that was just being handed around.
Yeah.
And then I chose Hibernate, and we got it working, and then we went into production, and in 10 seconds it failed. And we had to roll back.
Fail fast. This is like a very good concept.
So, actually, my partner was Adam Murdoch, who's the CTO of Gradle, just over there. So he actually had gone on vacation for 2 weeks. He left on Friday. The go live was on Monday. So it was all up to me. I didn't really understand concurrency very well at the time. So I spent about a week scratching my head and finally figured out that there was a bug in Apache Jcs, the caching project. So I created a patch for it. We patched our version. We got into production, and we ended up being for ThoughtWorks, we were at What If for about 5 or 6 years. They ended up exiting as $1 billion company. So, and the thing that spun out of that was I started with one patch to JCS, and then I told the Hibernate mailing list about it, and like, yeah, you should patch your JCS before you go into production. And then Gavin King heard about it, was all upset because this was his baby. He was trying to make it successful. And he said, the guy from JCS, it was summer in the US, and the guy was on vacation or not available, not responsive.
Yeah.
So he's like, why don't you fork JCS? And I'm like, that's a big step. And, in the end, he convinced me, and I said, okay, well, if I fork JCS, will you include that as one of the caches in the Hibernate distribution? He said yes. So I ended up forking it. Adam Murdoch actually came up with the name of JCache, and we worked on it together for a while. Then I kept maintaining it. And so this went along for a number of years. So JCache became successful, as you know.
Yeah.
What If became successful.
Yeah.
I eventually learnt concurrency.
Hard way.
The hard way.
Yeah, learning concurrency in hard way.
Yeah. And so then I was, I got paid by a large Silicon Valley company. I think it's NDA, so I still won't say who it was. But they paid for some consulting around JCache. And one of the things they paid for, what they wanted was they wanted me to implement JCache. So JCache had been created back in what are we, 2016? So it must have been about 2003. A guy from Oracle proposed the caching spec.
Mm-hmm.
And I think what they had more in mind was something closer to what Akamai is, like with edge-side caching.
Yep.
But done sort of like in a Java-friendly way. Anyway, it kind of languished for a while. It got partly done. I tried implementing it, which was a disaster because it was incomplete. Couldn't really implement anything, but I implemented what I could. And then as part of that, I joined the expert group. And then I was kind of like, somebody should really finish this. And so I met Cameron Purdy from Oracle, and he's like, yeah, well, I want to finish it. I've just been too busy. I'm like, well, let's try. So I became co-spec lead.
What year it was?
2007, probably.
Yeah, so I just want to emphasize that it's like JCache, like JSR 107 is one of the longest running the standards.
It's actually the longest running. It's the longest running JSR that ever successfully completed.
This is a good point. It was finally successfully completed.
And now they've actually changed the rules, and you get a if you go what's the word, like vacant. That's not. Everything slows down. There's no progress being made. Then I think it's once every 2 years under the current process. There's a vote to basically say you go to the 1 year. There she is. Hey, Heather. 1 year. So every 1 year, if you become inactive, then the JCP will proactively contact the spec leads, and then usually what they say is, oh yeah, we're still going.
Uh-huh.
But then it comes to a vote, and then we have a vote. Now, ironically, because I'm on the JCP Executive Committee, ironically, I'm actually a real hard ass on other people that have gone inactive. So I always vote to kill the JSR.
Oh, wow.
Yeah, because at the end of the day, like if everybody's just nice, everybody just says, okay, yeah, vote, like nobody gets a wake-up call.
Yeah.
If myself and maybe a couple of other people vote no, and I always put my reasons, then it's like a wake-up call, and it makes the spec leads either get going or really actually think hard about it.
Yeah.
So somebody should have done that. Somebody should have done that to 107 like many years before. So basically I'd partly implemented it, and because I'd been paid to do this, because like nobody, if you weren't being paid, you wouldn't want to do it.
Nobody get paid to write the standards like JSR standards.
So I kind of knew like some fundamental problems with it, but actually doing the spec ended up taking about 2 years of about 50% of my time. And there was also a counterpart over at Oracle. There was a guy called Yanis Cosmodopoulos, and then after him, Brian Oliver. And it was enormously time-consuming. So, as you said, we got it out in 2013.
Yep.
At this point, of all the in-memory data grids and distributed caches out there that are well known, everybody's implemented it except for IBM ExtremeScale and Pivotal Gemfire. Now, the IBM guys did actually say that they have a plan to implement it later this year. So that'll just leave the Pivotal guys, who still, despite constant requests from their customers, are still saying that they're not going to implement it.
So the thing is with what I like about the JCache spec itself, it actually doesn't force you to implement it for like in-process cache or distributed cache. So it's actually like a very good possibility for moving different parts of the application, like from in-process cache into the distributed cache, for example, just switching the jars. And because of the TCK and all this implementation need to pass the TCK and everything that, including like the consistency logic that explains the standard needs to be complied with. And this is kind of a very nice thing. So yesterday we had the ball for JCache in Java EE, and we had the people from the Payara, which is a commercial implementation of Glassfish, Tommy Tribe from a commercial implementation of the Tomcat-based Java EE server, and the multiple things that people already doing this is implementing the extension for CDI, for example, so they can intercept different calls and inject the cached values for certain places, which is like very nice way how they can like speed up the application performance, like very cheap, just cache everything. So, and yeah, this is one direction like that actually doesn't doesn't directly depend on what's happening with JCache right now. So the standard is there, a bunch of implementations. So the Java EE guys needs to form the alliance to bring this into Java EE.
Yeah, I mean, like when we did the spec was a little bit awkward because like you said, Pojo annotations are actually really useful.
Yeah.
Now that requires a dependency injection container, which is above and beyond the JDK.
Yeah.
So the JCache spec is a little bit unusual in that it only depends on the JDK. However, if you want to use annotations, then you need an annotations processing engine, which you get from CDI or you get from Spring or from Juice or something.
Yeah.
So what we did in the spec was in the reference implementation, so not the reference implementation, the TCK. In the TCK, we actually created test integrations with CDI, with Juice, and also with Spring to make sure that it would all work.
Mm-hmm.
And so it really shouldn't be that difficult to take that code and actually reuse that with an existing EE container. The Spring guys already added the JCache annotations back in Spring 4.1. So I don't know. This is what, from our point of view, we're done.
Yeah.
And we've defined the annotations. The annotations had a lot of thought put into them. The guys from Spring and Eric Dahlquist, who was the guy who originally created the Spring Cache annotations library, all those, Rick Hightower, all these guys were heavily involved, and bar a couple of bugs, it's done. And the Spring guys have adopted those.
Yes.
So it really just needs somebody on the EE side to go ahead and use those annotations and then glue it into JCache.
Yeah. So the problem with GE, like you said, it's many vendors already adopted this. The problem is that there's no like a standard things like the new standard like JSR and TCK that can be integrated with other components.
Has Payara already added the?
Yeah.
Okay. Well, the thing is, you know what I think is the best way to go. Everybody should just add the annotations in a proprietary way.
Yeah.
So the annotations are standard. JCache is standard. The binding, why don't they just do that in a proprietary way for each app server?
Yeah.
And then once everybody's done it, that then creates extra pressure on the EE community to actually standardize it.
Yeah. Yeah. So this is exactly what happens because the Payara has it, Atomic Tribe has it.
Do they really?
Yes. They're using the Apache, what the library you said? Like
JCS?
Yeah, JCS. This still using this.
It's still around, yeah.
Yeah. So we'll see how it goes. So in this like yesterday, Bob, they tried to like throw some ideas. There is a Adobe JSR project that has JCache for Java EE sub-project, and there are a bunch of ideas or like a ticket open there, like how to integrate JCache with GTA, like so the transaction can be propagated through the caching operation.
Okay, well in terms of JCache with JTA, that was originally part of the scope for 1.0.
Mm-hmm.
If anybody's interested in that, we actually have an entire chapter of the specification for how that should work. And also there's not much in the API, it's just a couple of methods, but we actually did all that. So we can actually, I can just get it back and email it to somebody.
Yeah.
If you let me know who that is.
Yeah. So definitely
that wheel
this information
doesn't need to be reinvented, we did it. And once again, around transactions, I work with my colleague at the time from Terracotta, Ludovic Orvan, who created the Bitronics transaction manager. And we also work with Brian Oliver. So we actually did a lot of work on it, and we were really happy with it. And then we were going to make it part of the spec as an optional part, but the JCP said that the reference implementation needed to provide a transactions implementation.
Yeah.
And we're like, oh man, nobody wanted to do the work.
It's in another 3 years.
What?
In another 3 years work. I'm not kidding.
Well, anyway, nobody needs to reinvent that wheel because we already did it.
Yeah. So now 2016, we have 10 implementations, both in-process caching and distributed caching solutions. So now, what is current state in terms of standard? So I know like you're working right now to releasing the 1.1. So what's going to be in the 1.1 and what's going to be next? Like after, what's you going to do after 1.1?
So we did do we did a lot of work on 1.0, and there's actually a very, very small bug count. And there's some, in terms of where the bugs are, there's just some things like, okay, it's a grammar error in the spec, or the spec will say something wrong, different to the Java doc. There is actually a concurrency issue in the completion listener, which Brian Oliver wrote, by the way. I had Peter Venture, who was involved in the fix for that. But by and large, the reason, like, there's 10 implementations. Some of those implementations have raised no issues, right? And then other people have been kind of very picky. But I don't know. So 1.1, the bugs came in pretty slowly. A lot of the so-called bugs were people that really just had questions about why was it done that way. So the reason it's taken kind of a period of time to put it out is because there was no urgency to really do it.
So it was finally like well written at the end.
Yeah,
it took time. It was well written when it was 1.0.
1.0, yeah.
Yeah.
So 1.1, the way it is right now, it's kind of pretty much ready to be released. So there's still, I would like to get it out in the next month or two. Like, I kind of would have liked to have gotten out by Java 1, but as I said, there's no super pressing issues.
Yeah.
One of the problems that you have is so I'm actually working on this myself, and then when I go and do some work on it, the problem we've always had with the spec is that it seems like a simple thing, but there's so many different points of view. So you go and work on something, and then people wake up from their slumber, haven't heard from them in 6 months, they see that some work got done, and then they're like, oh no, I want it like this. And there's actually some issues. When I release 1.1, there'll be some issues that are open because I close them and the reporter just reopens. You have this open-close crap going on.
Yeah.
So I just put a flag on it saying closed, right? Little color code saying closed.
Yeah. It's still like an open discussion maybe, but there's no like real bug.
So 1.1 should come out soon. As I said, so we'll put a maintenance request through. One of the things that held it up was last year I wanted to add asynchronous operations, and I actually defined those, and then had a couple of month argument with everybody saying, oh no, you can't add methods to an interface.
Yeah.
Technically you can if you look at the definition of binary compatibility, but it does seem to be against the spirit of things. So in the end I backed down. In terms of, but some ideas. So 1.1 should come out in the next few months, and then I expect that everybody that's implemented 1.0 will fairly quickly over the next in their next release cycle. So maybe 3 or 6 months they'll move to 1.1. From the point of view of end users, basically no different because it's really just an errata release.
Yeah.
And then
what about like next thing? So you talk about like async methods, and because of right now like the concept of async programming or reactive programming, becoming like more and more discussed topic, and the people talking about the things. And from perspective of the support of the library, Java 8 provides a completable feature that allows or enables that kind of reactive style of programming. So what do you think about this, and do you think it makes sense to have the support on the library?
I kind of really felt like we kind of missed it not adding async in, because most distributed implementations, including Hazelcast and Terracotta, actually have async methods. Because depending on the nature of the data, if it's okay to lose the data, like it's true cache data, then async is basically okay.
Yeah.
You want to just go as fast as you can.
Yeah, but in this case, you need to sort of refine the consistency guarantees and standards. So right now, it has a happens before type of semantics. So if one operation executed, so the next operation will see the result of previous operation, stuff like that. So in this async, you need to refine how this visibility and all this like happens before gonna happen. So and it might be different from perspective of in-process caches and distributed caches. So So the couple things. Yeah.
We did actually complete the before I abandoned it. So it's actually there on GitHub. We did complete the API changes, including the contracts on consistency. Can't remember exactly what they were right now, but
it's still in TCK somewhere, because the TCK sort of like it checks the consistency of every method.
that's in at the moment with synchronous methods.
Yes, with synchronous ones.
With synchronous methods, the consistency is very, very clear. It's strong consistency.
Yeah.
Now the spec says it's strong consistency. It also says that implementations may provide further consistency models. But obviously with async, you can't get strong consistency.
Yes.
And also, if you've got in process, it might be possible, but in a distributed implementation, you also can't provide ordering guarantees.
Yes.
So, but still async, because you know asynchronous operations always include batching. And it's actually the batching that gives you the performance improvement, because you know you're just doing.
Either doing one side, like a back pressure type of thing,
right,
when you do it on the client, or you're doing it on the server, you know, before you send it back. Yep.
There's an interesting algorithm with back pressure, by the way. So what we discovered at Hazelcast, and Brian Oliver said that they were using the same number in coherence. It was every, I think it was every 10th or 100th operation, you actually do a flush. So you actually flush the queue.
It's more like a heuristic, or like a...
It's a heuristic.
Yeah.
So when we, at Hazelcast, when we added the async methods, we actually tested, 10, 100, 1,000, 10,000. I think it was 100 that we settled on, and so does coherence. So that so that gives you most of the network savings, while at the same time giving you sort of, there's basically very, very little. It's like an asymptotic function.
Yeah.
So there's almost no performance improvement on actually going
after
over that,
this, like
over that batch number.
Exactly.
So it actually, the nice thing about that number, that heuristic, is it actually keeps keeps the buffers actually very small, so it doesn't create any memory issues or anything.
Right.
And so once you get to 100, then it causes a flush, which then naturally applies back pressure.
Yeah.
Yeah.
So now,
so the async,
about
the
the
async I
sync,
think would be really nice to be added, and then that would work well with reactive and all the other stuff going on.
Yeah.
The other thing on the flip side would be nice to probably do transactions. I think there's enough appetite out there to do transactions. Pretty much all of the distributed IMDGs have got transactions, so it'd be nice to standardize that area.
So what about? Okay, we know that caching it's not data store, so it's caching. It's a temporal data, but many people were asking about how about like getting data not only by key but also by certain properties that you store inside the cache. So it's sort of like a query type of language. Is it like a, do you think it makes sense to have it in the cache, or the cache should be, you know, solely temporal key value?
Well,
type
once
of
again, I mean, the approach that we've taken was to try and create useful standards around what already existed.
Yeah.
So you can take an empirical approach and just say, okay, well, if everybody's implemented something and it's a well-used feature, why don't we standardize it?
Yep.
Now, query does pass that test, query or predicate. However, where the problem comes in is what predicate language do you use? Because there's not a pre-existing JSR that we can just import and say we're going to use this one.
Or maybe something like JPQL from JPA that defines like the object query type of language, which is not like the SQL, or not direct translation to SQL, or it was designed to be a direct translation from the object model into the SQL model. So potentially JPQL, this is kind of thing that maybe makes sense. So you have a sort of JPQL statement where you can query key value store. I don't know. This is kind of some of the ideas that I heard from the audience.
The thing that we don't want to do is we don't want to define a caching predicate language.
Right, yeah, exactly.
Because that's just ridiculous, because you're not making the world better, you're making the world worse, you know.
Yeah, so it's still like there are some questions open, And I guess this is we or the Java one, and we're talking to the developers, we're talking to the people who like vendors, and this is why like it's good time to to have this time
I mean,
of conversation.
some nice things that have happened. Spring adopted it recently. Hibernate, was it 5.2?
Yeah.
5.2 actually added JCache as a provider. Spring guys like Spring Boot have got JCache as a provider. So over time, so we've got the implementations, and then what's really nice is that the whole point was so that
Frameworks
could actually use it. And of course, the other benefit is for end-using companies, so they don't have to have a dependency on a specific implementation. And like you said, you can very easily switch from an in-process to a distributed without a lot of rework.
Yeah.
One thing that we've learnt out of all this is that in your true in-memory data grid use cases, caching itself is only a minority of what people do with in-memory data grid.
Yes.
So.
An entry processor, it's another kind
of.
More like a
we added entry
computing part.
processor, which was like a nod in that direction.
Yeah.
Because that's the most widely used in-memory data grid feature. But I would say that in terms of adoption in industry, like financial services, which is the heaviest user of in-memory data grid, are also probably the least adopters of JCache.
Yeah.
And it's because their usage is more complex.
Exactly.
So like in Hazelcast, the cache API is maybe 5 or 10% of the whole API. And the thing is, it's kind of hardly worth messing around with JCache if you've already got a proprietary dependency. But I can't really see anybody kind of going out. I mean, we could take JCache and extend it to more IMDG, but you get a lot more variability on approach once you move outside of caching.
Yes, another thing what you just said about the financial companies, and another thing that just struck to my mind, that the microservices world, and I know you're gonna join the panel on the night hacking about microservices. So just to quickly, like we're also like running out of time already.
Which I don't claim to be an expert on, by the way.
Yeah, but still, do you think the JCache makes sense in things like microprofile, which the vendors of enterprise application servers proposing right now? There's like the microprofile for like building and deploying microservices or web application using microservices. Do you think like a JCache has some potential in this area, like for example, like help to integrate different parts of the system, or the cache storage can be used as a backbone for interchanging the data between them?
Well, as I said, I'm not a microservices expert, but my perspective, I mean, what was interesting actually at whatif.com, we started with a monolithic application, and we realized that was a big part of the problem. So we ended up, how much time we got left?
We're already over.
Oh, well, we can wrap it up. But we broke a monolith into about 15 services, 15 microservices. So we had one.
What year it was?
This is like a long time ago.
2000-ish.
This was 2000, and we started the process of breaking it apart in like 2006 or something. Yeah. Through till about 2009. And so the idea worked very well, but the infrastructure was much more complex. Yeah. But anyway, each microservice is basically a full stack application. So the thing that you have to ask yourself is, okay, do I need caching in the monolith? Right? If you need caching in the monolith, then once you decompose that into microservices, some of those, maybe not all of them, but some of them will need caching. And so Hazelcast is very popular for microservices, and why not use JCache there? But the key thing is isolation. So the key thing to remember is that you want a separate cluster per microservice. Right. So you've got true isolation. But yeah, I think the microprofile guys, look, EE is going to be too slow. Why don't they add JCache? There's a lot of demand for it.
Exactly. Yeah. So this is why you're also interested in adding JCache. So we're almost like. We already ate our time, so thanks for your time for talking about the JCache.
Thank you, Victor.
And stay on the Night Hacking channel. There's going to be very awesome discussions, and going to be like a tomorrow panel about the microservices.
This afternoon, I believe.
Oh, this afternoon. So stay tuned if you want to learn about like microservices in Java world. Thanks again, Greg Luck from Hazelcast and Victor Gamma from Hazelcast, and also Greg Luck, co-lead of JCache spec. Thank you very much, guys, and stay tuned with the new stuff. Thank you.